So welcome back, and we're now going to just look at many-sided shapes, and we're going to look at the sum of the angles of these shapes. So we on page 109, and we've got names for these shapes. We obviously know about a triangle, three-sided, quadrilateral, four-sided, pentagon, 5, 6, hexagon, etc. All right. Now, so here's an example. When we talk about a regular polygon, what we're saying is that all its sides and all its angles are equal. Okay, right. So here, for example, is a pentagon, and here's a regular pentagon. With the regular pentagon, what we know is that all the sides are equal and all the angles are equal. So in other words, this angle is equal to 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 this angle. What we're going to play around with now is, what are the angles of a pentagon? Okay. And what we already worked out is, we know that a quadrilateral, 4 sides, we can make 2 triangles and we get 180 degrees. With a pentagon, this is a pentagon, 1, 2, 3, 4, 5 sides, how many triangles can we make? Well, we can make a triangle to there, and we can make a triangle to there. All right, so in fact we could make 3 triangles. All right. And if we think about adding up all the angles of the 3 triangles, so I'm just going to put all red dots on all of those, all the angles of the 3 triangles, I think you can see we're actually going to get all the angles of the original shape. All right. Okay. So, sorry, this I said 5. This has got 5 sides. How many triangles can we make? We can make 3. And we ask you to look for patterns here. So the total number of angles of degrees of all the angles in a pentagon will be 3 lots of 180 degrees. It's actually 540 degrees. Now, if we have a regular pentagon, then it's got 5 angles, and so each angle will be equal, and in fact each angle will equal 108 degrees. Okay, so if we go and look at this shape over here, these angles are actually each 108 degrees. All right, and we've managed to work that out. The next shape we want to look at is a hexagon. How many triangles can I put into a hexagon? Well, if I choose a point, I can make a triangle to there. I can make a triangle to there. All right, very irritating. Sometimes my lines are so bad that it won't straighten them up. All right, those 2 are meant to start at the same place, by the way. And I can make a triangle to there. How many triangles? 4. So 4 lots of 180. Now 4 lots of 180 is actually 720 degrees. And there's 6 angles. So the total number of degrees is 720. If we add up all the angles, 720 divided by 6, 120 degrees. In a hexagon, every interior angle, a regular hexagon, everyone is 120 degrees. What about a 7-sided shape? How many triangles can I form? Okay, I can form 1, 2. I can go make a triangle to there. I can make a triangle to there. All right. I haven't drawn these sort of very nicely at all because they should all come from this point. 1, 2, 3, 4, 5. All right, so now it'll be 5 times 180. 5 times 180 is 900 degrees. So in a 7-sided shape, all the angles add up to 900, and each angle will be 900 degrees divided by 7. Okay, here's an 8-sided shape. I'm not going to draw them, but let's try and look for a pattern here. 7, 5, 6, 4, 5, 3. Any guesses on 8? Absolutely. 8 is actually 6. All right, so 6 times 180. Okay, and we can work out what 6 times 180 is. I'm not going to need a calculator, which I shouldn't, but I'm a little bit tired, so let's try it. 6 times 180. 6 times 180, and we get 1080. And if we divide by 8, because remember we've got 8 angles, each angle is 135 degrees. Okay, so 1080 divided by 8, 135 degrees. Okay, right. So we've kind of got this picture. Now this is a 9-sided and then a 10-sided, and we're not going to fill all of this in. But if we had an n-sided figure, how many triangles could we make? Well, let's have a look. It's always 2 less, so n minus 2. What would the total degrees be? It would be n minus 2 times by 180. So in fact, it would be 180 times n minus 2. Or 180n minus 360. Now, if I've got an n-sided shape, then I've got n angles, and each angle will be 180n minus 360 divided by n. Okay, so that is a formula that we've now created for an n-sided shape. There's another way of thinking about this, right? If we walked around a shape, okay, the whole way around a shape, turning in the same direction each time. So in other words, we walked here and then we turned to our left and then turned to our left and turned to our left. When we've walked right the whole way around, we'd be facing in the same direction that we started in. So we will have turned around 360 degrees. So for any polygon, any multi-sided shape, when we walk around it, the exterior angles, all these exterior angles, always add to 360 degrees. Okay, so for example, if we were going around a hexagon, a regular hexagon, there would be 6 exterior angles for 360 degrees, and that would mean each exterior angle would be 60 degrees. And if we look at the exterior angle and the interior angle next door, they're supplementary because they're on a straight line. So each interior angle of a hexagon would be 120 degrees. And if we go back to here, you'll see that's exactly what we got. Okay, this is just a sort of an extension exercise. It's not that important, but it's interesting. All right, and if we did the same thing for a hexagon, for an n-gon, in other words, n-sided, then each exterior angle, remember all the exterior angles add to 360 degrees, so each exterior angle would be 360, remember there are n angles, so 360 divided by n, and so each interior angle, remember those are on a straight line next door. If this is an exterior angle, here's the interior angle. Each interior angle would equal 180 minus 360 over n. And if we go back, and just remember that number there, 180 minus 360 over n, if we go back to the way we first did it, using triangles inside, there we've got what looks very similar. And if we split this fraction into 180n minus 360, and we put both of them over n, all right, then this actually simplifies to 180 minus 360 over n. And 180 minus 360 over n is a little formula which gives us the internal angle of a regular n-sided shape, and it's exactly what we got over here. Okay, so now there's a little bit of opportunity just to do some practice. We're going to ask you to pause the video and try these, and then we'll go over them. Okay, so what we've got here is a 1, 2, 3, 4, 5-sided shape, all right? And we know that for a 5-sided shape, if we go back to our table, each angle is 108 degrees. So for this one, we know that 4x plus 8 is 108 degrees. Okay, and I'm just going to write here pentagon. So now we can solve this. Subtract 8 from both sides. 4x is 100. Divide both sides by 4. X is 25 degrees. Okay, right. This here is how many sides? 1, 2, 3, 4, 5. All the angles of a pentagon add up to 540. So what we actually know is if we add all of these up, all right, that we must get 540 degrees. Okay, if you're wondering how we know that, let's go back to our table here. Pentagon, the angles add up to 540 degrees. Okay, so we know that, let's just add this up as we go around, x plus x plus x plus x, 5 x's. We've got 8 and 8, that's 16, and 32, that's 40. That's 48, minus 8 is 40. So 5x plus 40 is 540 degrees, and the reason is because it's a pentagon. If we now subtract 40 from both sides and divide both sides by 5, we get that x must be 100 degrees. Okay, the interior angles of a regular polygon is each equal to 162 degrees. How many sides does it have? Now remember, our little formula for each interior angle is 180 minus 360 over n. So n is the number of sides. We want 180 minus 360 over n to equal 162. And we need to solve that equation. Okay? So let's let's subtract 162 from both sides first. All right? And we actually get 18. And let's add 360 over n to both sides. Right. Now, we've got a fraction here. What can we multiply both sides by to get rid of the fraction? That's right, by n. So 18n is 360. What should we do lastly to get n? Divide both sides by 18 and we get 20. So a 20-sided figure has each angle equal to 162 degrees. What do the interior angles of a 30-sided figure add up to? And I want you to think, if there's a 30-sided figure, how many triangles can we make? Well, 2 less than the number of sides. So, in fact, the angles will be 28, all right? 28 triangles. So 28 times 180. Okay, and let's work out what that is. 28 times 180. 28 times 180. And we get 5,040 degrees. So a 30-sided figure, the angles will actually add up to 5,040 degrees. If it's a regular figure, in other words, each angle is the same, then we can work out the angle size by just taking our 5,040 and dividing by 30. Okay, and we get 168 degrees. Okay, so a 20-sided figure has angles of 162 degrees each. A 30-sided figure has angles of 168 degrees. Okay, and what happens to the interior angles of a regular polygon as we increase the number of sides? Well, it increases. Okay, and then what's the largest number of sides a polygon can have so that its interior angle will be an integer, a whole number? Right, now remember the interior angle is actually 180 minus 360 over n. 180 minus 360 over n. Right, so we want n to be as large as possible. But if n gets bigger than 360, we're going to get a fraction here. All right? And then we're not going to have an interior angle size. If the biggest number that n can be to make this a whole number is 360. if n equals 360 degrees, all right, then each interior angle will equal 179 degrees. All right, which is pretty much almost a straight line. Okay, so I'm going to try and just show you a little picture, which will hopefully help you understand what's going on here. Okay, so what we've got here, we've got a pentagon inside a circle, all right? And we could measure that angle, and it will be 108 degrees for a pentagon. Okay, now what we're going to do is we're going to change that. Instead of it being a 5-sided figure, we're going to make it a 6-sided figure. Okay, we're going to probably need to, I need to just delete that. I could remeasure this angle, all right? And notice that the angle is actually getting bigger as the number of sides is increasing. Let's take this shape and let's give it a whole lot of sides. Let's give it 20 sides. And you might remember the angle size for a 20-sided shape. I think it was 162 degrees, okay? And you can see that it's actually almost looking like a circle now. But if we go and measure one of these angles, okay, and it's actually not allowing me to measure it, there's sort of too many sides here, okay? But the biggest angle we can actually get is 179 degrees, the biggest whole number angle. All right, I'm just going to undo that, and I won't go as far as 20 this time. Let's go to 12 sides. Right, and you can see it starts to almost fit into the circle, but what's happening is that these angles here are getting bigger and bigger and bigger. Then there's a 150 degree angle this time. Okay, I hope that sort of helped a little bit with the understanding. Right, and that brings us to the end of the term's work. Right, don't worry too much about this last piece of sort of using triangles. It's just a nice little extension exercise. But what you do need to be comfortable with is all the other stuff that we've studied. At the end of your book, there's some blank pages, and you can make up some extra examples. Your teacher can also give you some extra examples. All right, have a wonderful holiday when it arrives. Goodbye, everybody.